Hello, Olivia. This is Mr. Gibson, and I wanted to go over the questions that you had for me for Project 25 and also Project 27. So I want to jump right into this. So with Project 25, I have it side by side with the Desmos graph here. Okay, so first of all, it said create a new Desmos graph. You know how to do that. And then the note box, and we're going to do the last four digits of the phone number of your phone number, but I'm going to use the actual digits that they provided here. So my A is going to be 7, B is 8, C is 9, D is 0. Now it tells us to graph the two quadratic functions. So we could do it f of x and then equals, it'll be x squared and then plus, now my A is 7, so it'll be 7x and then minus my B is 8. Okay, that's the first graph. I'm going to make it a little smaller here. Now, the second graph, we will have g of x is equal to negative x squared plus, now c here is 9, 9x, and then it'll be plus 0. Okay, so now it says for number 4, locate, jot down the intersection points, then graph them as ordered pairs. Check the label box to display the ordered pairs with their coordinates. Okay, note you could graph many ordered pairs on one line by using a comma to separate them. Okay, I have to pull this graph down. Okay, we want to deal with their intersection points. Here's one intersection point here. So we had 2.562 and 16.492. So let's do this. Parenthesis. Let me look at that again. 2.562, comma. What's the other value? 16.492. Now we click on a label. Now we do have the label here of that point, but we should put intersection point as well. Well, actually, that'll take away the ordered pair. So we could just leave the label for the ordered pair. All right. So now we go down here to the second ordered pair. This ordered pair is a negative 1.562. And then a negative 16.492. And then we will have our other point. So those are our two intersection points. Now it says number 5, solve the inequality f of x is less than or equal to g of x. Use a note text box to state this solution. All right. So we want to go f of x. All right. For this problem here. Okay, we look at our x values of our intersection points. Because if you notice here, the f of x graph is black and the g of x graph is red. And you notice here doing these intersection points, let me make this a little smaller. Or make this a little bigger here. Pull this down here. All right. Now if you notice here, when we get into this area here from when x is negative 1.562 and then x is what's that, 2.562. If you notice here, the g of x ends up becoming greater than the f of x on the outside of this here. So we want to figure out, yes, at every point here in between these two values here, the g of x value is always higher than the f of x value at those same points up until we get here, this intersection point, and also below this intersection point as well. So if we were going to put a note here, we would say that x must be, what's that, that negative 1 point, well, I guess I should say greater than negative 1.562, but less than, oh, you know what, I forgot, it was supposed to be or equal to. So instead of the greater than, it should be must be, because I forgot the or equal to. So x must be negative 1.562 to 16 plus to 2.562 for the inequality to be true. So basically what I'm saying here is that x must be this value to this value here in order for that inequality to be true. Now it says here, use inequalities and or restricted domains to shade the solution to the inequality f of x is less than or equal to g of x. In other words, shade all y values between f of x and g of x. So what you're supposed to do here, you just go f parenthesis x, and then it's supposed to be less than or equal to, so we have to hit this less than or equal to g of x. And as you see here, it shaded the area. Now I could show it a lot better here. So it shaded the area in between those values. So this is basically what you were supposed to be looking for from exercise 25. So now we're going to go on to project 27. So what I'm going to do, I'm going to get another blank graph, and then we can start this off. So this was 26. No, this is 27. It says, create a new Desmos graph and create a node. You know how to do that. Open a win-cost data set, then create a scattergram. All right. So first thing, we go here. I think I got to hold down control. Yes. Okay, now what this is telling us, I'm going to move this over here. We need to type these values into Desmos. So we will go here, get us a table in Desmos, and we know our T is our X1 and our C is our Y1. So we would type in those values. We got 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, and it goes up to 20. So now we type in the values. We have 56, 46, 37, 28, 22.5, 16.5, 13, 10.5, 7.5. Let me move this over a little bit. And then we will have 6 and also 4. All right. So I believe that's all we actually needed from that. Now, once you put in these values, oh, wait a minute. My last two values didn't go. So it's supposed to be 6 and also 4. All right, there we go. All right, now we got in our values. Now it says use Desmos to find a quadratic regression. Now I believe that this is where things got a little trippy for you. So we're going to correct that. We wanted quadratic regression. And so to do quadratic regression, remember the quadratic equation is y equals ax squared. And I'm just going to type out the regular expression, ax squared plus bx plus c. Now this is the equation that we're supposed to use. So we have to convert this now in order to get the quadratic regression. So the first thing we have to do, we're going to have to get rid of this equal sign and put the tilde in its place. We're going to have to make, well, this y, we have to make that y1. And this x, we have to make it x1. This bx, we have to make that bx1. Now here, we have our values for our equation. Now it tells us, standard form, use Desmos to find a quadratic regression. Now we found our values, but we have to write it as a quadratic regression. So we will substitute these values in for A, B, and C. Now to plot the vertex of the model as an ordered pair, okay, now here's the issue with the vertex. What you're going to have to do in order to do the vertex is this here. You're going to have to use the vertex formula. Now, if you don't remember the vertex formula, I'll give you the formula to find x, and then you will go back in the equation to solve y. So the vertex formula, you're supposed to take the opposite of whatever b is, divided by 2a. And it actually gives you the value here. So this would be your x value of your intercept. And then to find the y value, you will substitute this value in here. So I believe, if I'm not mistaken, I believe that you basically have this. But what you didn't do, one, you didn't write out the equation, the quadratic equation. Then two, you didn't find the vertex, which now you have an idea how to find the vertex. This is how you find your x value, and then you will go and substitute the value in to get your y value. And then you have to mark the ordered pair. Okay, and then you have to use the note text box to explain what the vertex means in terms of this situation. I know you know how to do that. And then what is the practical domain of the model? Okay, look, if you look at this model here, you know you cannot have negative watts of energy. So that is the only hint that I'm able to give you as far as the practical domain. You cannot have negative watts of energy. Now it says use the model to predict when wind power will cost 20 cents per kilowatt. So you know how to solve that equation. And then number 8, how much do you think wind power will cost in 2020? Okay, now I got rid of this set of data a little too soon because number 8 is a little tricky. But let me show you this here. It says in 2020. Now when we look at this graph here, this graph is it starts at 1980. So you have to take that into consideration when you're doing the 2020. That's a little hint. And so we're basically done. And I hope if you have any other questions, please contact me.